Hi students, today we are going to discuss about the engineering chemistry unit 1 water chemistry, softening of the water or different conditioning methods of the water. Okay, then what is softening or what is conditioning? So I told the water should have the various impurities from the different sources. So in that impurities we have to remove from the water. In that method we are called as the treatment of water or softening of the water or conditioning methods of the water. Okay. So in generally water used for the industrial purposes should be free from hardness producing substances and suspended impurities and dissolved salts. Suppose if the water having any types of the hardness producing salt, suspended particles and dissolved gases, it will be produce some troubles that are called as the boiler troubles. Okay. So the process of removing hardness producing salts from water is known as the softening or conditioning of the water. Once again I repeat, so the removal of different hardness producing salts from the water and making it fit for the domestic as well as the industrial purposes is called as the softening methods or conditioning of the water. So what are all the different types of the conditioning of the water? So there is the mainly two methods. One is the external conditioning, another important one is the internal conditioning. The external conditioning means the water before feed into the boiler, we have to remove all types of the impurities from the water, that is called external treatment. Suppose some of the chemicals directly added inside the boiler to treat the or to remove the various impurities present in the water, that is called internal methods or internal conditioning. Are you understand? So the before add water into the boiler, we have to treat the water is called external treatment. After adding the water inside the boiler, directly remove the impurities from the boiler is called internal conditioning. Okay. Okay. Now what is external conditioning? What are all the different methods we have to use the external conditioning? So it involves the removal of hardness producing salts from the water before feeding into the boiler. Okay, understand? It involves removal of hardness producing salts from the water before feeding into the boiler, that is called external treatment. The external treatment can be done by two methods. One is the demineralization process. The another name of the demineralization process is called ion exchange process. The next one is zeolite process. So these two methods we have to predominantly use to remove the hardness producing salts from the water. One is ion exchange process or demineralization process. Another one is the zeolite process. So we will see one by one. Demineralization or ion exchange process. What is demineralization or ion exchange process? So the process of removing almost all the ions. The totally two ions are possible. One is the anion, another one is the cations. So these two ions can be removed from the water is called demineralization or ion exchange process. So demineralization process is carried out by the using ion exchange resin. Resin means gum-like substances, which is long chain cross-linked insoluble organic polymers with micropores structure. The functional groups attached to the chain are responsible for the ion exchange process. First, cation exchanger. What is cation exchanger? If the resins containing acidic functional group means carboxylic group like COOH or sulfonic acid group SO3H. So these two groups are the acidic functional group, are capable of exchanging H plus ions in the water. The other cations of hard water cation exchange resin is represented as the RH2. So the function of the cation exchanger which absorbs the or which exchange the H plus ion, and it can be allowed only the H plus ion into the water. So the remaining ions it can be absorbed. So generally the cation exchange resin is represented as the RH2. R means resin, H2 means acidic functional group. Okay. The main example of the cation exchanges are the sulfonated coals and sulfonated polystyrene. So these two are the commonly used to cation exchange resins. Okay. Then anion exchanger. What is anion exchanger? So the resins containing basic functional group like NH2. NH2 means amine like group, and OH means hydroxyl group. So these two groups are the examples for the anion exchanger. Basic functional group are capable of exchanging their anions with other ions of hard water. So the anion exchange resin is generally represented as the R-OH twice. R-OH twice. So the anion exchanger which allows the which exchanges the acidic functional group anion basic functional group like as the OH and NH2 minus. So the main examples of the anion exchanger, one is the cross-linked quaternary ammonium salt and commonly used as the urea formaldehyde resin. The urea formaldehyde resin formula is the RNH3OH, ROH, RNH2, that which is equal to R-OH twice. So in generally cation exchange resins are represented as the RH2, anion exchange resins are represented as the R-OH twice. Okay. Now we are going to discuss about what are all the process mechanisms involved in the cation anion exchanges and demineralization process. Okay. So the hard water first pass through a cation exchange column. So you see the diagram. So here it is the schematic diagram of the anion cation exchanges. That means demineralization process, ion exchange process. The first column we are called as the cation exchanger. Then the second column we are called as the anion exchanger. So in the cation exchanger containing the cation exchange resin, that means RH2. In the anion exchanger column containing the anion exchange resin, that means R-OH twice. So first we have to pass the raw water into the cation exchanger column. The side arm of the cation exchanger containing the dilute HCl which is used to acid for the regeneration process after completion of the cation exchanger. The same thing like as the anion exchange resin side arm containing the dilute NaOH which is used to regenerative system of the anion exchanger after the process. So that is the diagram, schematic diagram of the demineralization process. So now we have to see the what is the reactions involved in that cation exchanger column and anion exchanger column. So the hard water first pass through the cation exchanger column. What will be happen? Which absorb all the cations like calcium 2 plus, magnesium 2 plus, Na plus, K plus, etc. What are all the possibilities of the cations available in that water, and all type of the cations which absorb the cation exchange resin. So the cation exchange resin we are represent as the RH2. Suppose we have to pass the water into the top of the cation exchanger column, that is the raw water. Suppose in that water containing any impurities, here I given the example for the calcium chloride. So in that calcium chloride react with RH2. The R absorb the calcium 2 plus to form RCA. You understand? The RH2 react with the calcium chloride. So here the calcium chloride cation is the Ca2 plus, anion is the 2Cl minus. So in that cation absorbed from the resin like R to form the RCA, and the H2 react with the Cl2 to form the 2HCl. That means 2 hydrochloric acid, which goes to the anion exchanger column. So in the cation exchanger column, RH2 changes into the RCA. Are you clear? Suppose in the second reaction, if the water containing magnesium sulfate, what will be happen? In that magnesium sulfate react with the cation exchange resin, that means RH2, to form the RMG, that means resin with magnesium. The resin absorb the cation here magnesium 2 plus to form the RMG. In the H2 react with the SO4 2 minus to form the H2SO4. So this is the second reaction. Suppose if the water containing common salt like sodium chloride, so here sodium is the cation, chloride is the anion. In that sodium absorbed by the resin to form RNA, then to form the HCl. So these are all the some of the sample reactions of the cation exchanger column. So in that cation exchanger column commonly absorb the cations like calcium, magnesium, sodium, potassium. Then cation exchanger allows the HCl, H2SO4, HCl to the anion exchanger column. So the cation exchanger changes into RH2 into RCA or RMG or RNA or K. So it is the mechanism involved in the cation exchanger column. Okay. The cation free water is then passed through an anion exchange column which absorb all the anions like Cl minus, SO4 2 minus, HCO3 minus, CO3 2 minus present in the water. Are you clear? So in the cation exchanger column allows the HCl, H2SO4, HCl into the anion exchanger column. In that anion exchanger column containing the anion exchange resin like R-OH twice. In that R-OH twice absorb the all the anions content in the water to form the demineralized water. Okay. So what are all the reaction mechanism involved in the anion exchanger column? We have to see one by one. So the first R-OH twice react with 2HCl. The 2HCl coming out from the cation exchanger column to form the R-OH Cl2. So here Cl is the anions. So the anion exchanger absorb the anions like a Cl minus. So that to form the R dash Cl2 plus 2H2O. In the 2H2O is the very pure water. It should be free from the anions and cations, so that it is called as the DM water or demineralized water or ion exchanged water. Okay. Suppose the water coming out from the cation exchanger column having the H2SO4, what will be the reaction involved? In that H2SO4 react with R dash OH twice to form the R dash SO4 plus 2H2O. So here the sulfate is the anion. So the sulfate react with the resin to form the R dash SO4 and 2 water is formed. The 2 water we are called as the DM water, that is demineralized water, 2H2O. Are you clear? So very simple. Suppose if the water containing calcium chloride, calcium is absorbed by the cation exchanger column, chloride is absorbed by the anion exchanger column. That is the main simple reaction. Suppose if the water containing magnesium sulfate, the magnesium is absorbed by the cation exchanger column because magnesium is the cation. The sulfate is absorbed by the anion exchanger column because sulfate is the anion. Okay. Suppose if the water containing NaCl, Na plus is absorbed by the cation exchanger column because Na plus is the cation. Suppose chloride is the anion, so the chloride is absorbed by the anion exchanger column like R dash OH twice. It is the simple reaction. Okay. So you have to write more examples by the one by one. So which is very simple reactions. So which is easily understandable. Okay. So already I discussed the diagram, what is the mechanism involved in that different columns. The cation exchanger containing cation exchange resin like R H2, in the anion exchanger column containing the R dash OH twice. So if the raw water containing any type of the hardness producing salt, so the cations are absorbed by the cation exchanger and anions are absorbed by the anion exchanger at the final column of the anion exchanger to produce the deionized water. So now we are going to the regenerative reactions of the two different exchanger, cation exchanger and anion exchanger. So the water coming out from the anion exchanger is completely free from cations and anions, so that it is called demineralized water or deionized water. So in that examination ask the what is DM water. So the in ion exchanger column, the water coming out from the anion exchanger is completely free from the cation and anions. In that water we are called as the demineralized water or deionized water. It should be free from the all the cations and anions in that water. For example, calcium, magnesium, potassium, sodiums are the cations. It can be free. The same thing like as the chloride, sulfate, any type of the anions also free, so that it is called DM water or demineralized water. Now we are going to the regenerative system of the anion and cation exchanges. At one particular stage, all the cation exchange resin RH2 are exhausted. After exhausted of the RH2, suppose we have to pass the water, raw water, there is no process, there is no absorbing process of the cations occurring in the column. The same thing like as the anion exchanger column, R dash OH twice. At one particular stage, the R dash OH twice also exhausted. There is no process will occur. There is no absorption of the anions in that column. Now we have to stop the raw water passing into that column. Now we have to use the regenerative chemicals. In cation exchanger column side, we have to use the dilute HCl solution. In anion exchanger column side, we have to use the dilute or aqueous NaOH solution. Now we have to see the what is the mechanism or what is the reaction involved in the regenerative process or regeneration process. Okay. First, acid regeneration. When the cation exchange resin, that means RH2, is exhausted, it can be regenerated by passing a solution of dilute HCl or dilute H2SO4 into the cation exchanger column by the side arm. What is the reaction involved? The RCA means after absorbing the cations from the water, the RH2 can be converted into the RCA. So in that RCA react with the regenerative chemicals of the 2HCl hydrochloric acid to form the again RH2 plus CaCl2. So CaCl2 which is evolved from the water. So it is the reverse reaction of the cation exchanger column. So the RCA react with the 2HCl to form the RH2 plus CaCl2. The reverse reaction is called as the main reaction. So you have to see the different types of the chemicals used into the different types of the salt present in the water. Based on the salt we have to write the different reactions. So here RCA. Suppose if the water containing magnesium salt RMg react to the 2HCl to form the RH2 plus MgCl2. That is the magnesium salt reaction. Okay. Next, alkali regeneration. Alkali means base. Similarly, when the anion exchange resin is exhausted, it can be regenerated by passing a solution of dilute NaOH. So now we have to stop the raw water. Now we have to add the NaOH solution into the anion exchanger column. In that anion exchanger column containing the R-Cl2 or R-SO4. What will be happen? In that R-Cl2 react with the 2NaOH to form the R-OH twice plus 2NaCl. The R-OH twice is the anion exchange resin which can be exhausted, regenerated after the process. Okay, so these are all the various mechanisms involved in the ion exchange process. So once again I repeat. So in the ion exchange process we have two columns. One is the cation exchanger column, another one is the anion exchanger column. In the cation exchanger column containing the cation exchange resin. So the best examples for the cation exchange resin is the sulfonated coals. So in the anion exchange resins we are represented as the R-OH twice. The best example for the anion exchange resin is the urea formaldehyde, which is represented as the R-OH twice. In cation exchange resin we have to generally represent as the RH2. Now we have to pass the water, that is the raw water, into the cation exchanger column. In the cation exchanger column absorb all the cations from the water. For example, if the water containing calcium, magnesium, sodium, potassium, all the resins which absorb the cations like calcium, magnesium, potassium, sodium. So the calcium, magnesium, potassium, sodium free water should be goes to the bottom of the cation exchanger column, that is called as the HCl and H2SO4 to the anion exchanger column. So in that anion exchanger column absorb all the anions present in that water. For example, if the water containing chloride, carbonate, bicarbonate, sulfate, so in all the anions are absorbed by the R-OH twice. That means anion exchange resin to produce the DO water, demineralized or DM water to the bottom of the column, so which can be used into the boiler, that is the softened water. At one particular stage, cation exchange resin and anion exchange resins are exhausted. Now there is no process will occur. Now we have to stop the water, impurity water into the cation exchanger column by using the regenerative chemicals like in the cation exchanger column we have to use the dilute HCl. In the anion exchanger column side we have to use the aqueous NaOH solution. By passing the dilute HCl solution into the cation exchanger column, the RCA can be regenerated to form the RH2. That means cation exchange resin RH2. The same reaction will occur, same thing like occur in the anion exchanger column also. In the anion exchanger column we have to pass it into the NaOH solution. In that NaOH solution react with the R dash Cl2 or R dash SO4 2 minus to form the R dash OH twice. Again the anion exchange resins can be regenerated. Now we have to stop the regenerative chemicals into the column, but now we passed into the raw water. Again the process will occur. So this process will occur based on the how much amount of the cation exchange resins inside the column and how much amount of the anion exchange resin inside the anion exchanger column. So this process will continuously occur based on the regenerative chemicals. Okay. So you have to write the repeated reaction, the both main reactions and the regenerative reactions. You have to give the more writing practice. That only you get the very good marks in the university examination and all the exams. So you give the more number of writing practice in the chemical reactions. Okay. Now we are going to the advantages of the ion exchange process. What are the main advantages of the ion exchange process? The highly acidic or highly alkaline water, that means highly basic water, can be treated by this process. That is the first advantage. Then the water obtained by this process will have very low hardness. That means nearly below 2 ppm hardness. Hardness means calcium magnesium salts. Calcium carbonate, magnesium carbonate, calcium bicarbonate, magnesium bicarbonate, then calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. All the ions are which easily absorbed by the cation exchanger column and anion exchanger column. So the zero hardness also to produce the demineralized water, DM water at the bottom of the anion exchanger column. That is the main advantage. The first advantage is highly acidic and highly basic water can be treated by this process. The second advantage is the zero hardness, nearly 2 ppm hardness also to obtained from the process. That is the main advantage. Then what are the limitations or disadvantages of the ion exchange process? If the water containing turbidity, muddy like substances, then the water the containing the iron Fe and manganese cannot be treated because the turbidity reduces the output of and Fe manganese form stable compound with the resin. So the resin will affected. So in that resin not supported to the Fe manganese like ions content in the water. So the turbidity water and iron content water, manganese content water does not helpful to this process. So this is the main disadvantage of the process. Then the equipment is very costly and the more expensive chemicals are needed because urea formaldehyde and anion exchange resins are called as the sulfonated coals. These resins are very costly. So that is the main disadvantages of the ion exchange process. Okay. So in the today's class we have to what is the demineralization process, then what are the chemicals we have to use in the demineralization columns and ion exchanger columns, what are the different types of the chemical reactions involved in that demineralization process or ion exchange process, then how can we regenerate the cation exchange resin and anion exchange resin with supportive chemicals and supportive reagents, Then what are all the different types of the reactions involved in the main and regenerative system, and some advantages of the ion exchange process and disadvantages of the ion exchange process. The question is will ask in the 8 mark, so you have to thoroughly write the different reactions and draw the diagram. More time the writing practice, that only you will get the very good mark in the university examination. So prepare well. Thank you one and all. Thank you.